Quadrilaterals are polygons with 4 sides and 4 vertices. They can have various properties and characteristics based on the lengths of their sides, the measures of their angles, and the arrangement of their sides and diagonals. Here are some important concepts and properties related to quadrilaterals. Types of quadrilaterals. A. Parallelogram. A quadrilateral with opposite sides parallel. B. Rectangle. A parallelogram with all angles equal to 90 degrees. Circa square. A rectangle with all sides equal in length. D. Rhombus. A parallelogram with all sides equal in length. E. Trapezoid. A quadrilateral with one pair of opposite sides parallel. F. Kite. A quadrilateral with 2 pairs of adjacent sides equal in length. Angle properties. A. Interior angles. The sum of the interior angles of any quadrilateral is equal to 360 degrees. B. Opposite angles. Opposite angles in a parallelogram are equal in measure. Circa consecutive angles. Consecutive angles in a parallelogram are supplementary. Their sum is 180 degrees. D. Right angles. Rectangles have 4 right angles. Side properties. A. Opposite sides. Opposite sides of a parallelogram are equal in length. B. Consecutive sides. Consecutive sides in a parallelogram are parallel. Circa diagonals. Diagonals of a parallelogram bisect each other. They intersect at their midpoints. D. Diagonals of a rectangle and square are equal in length and bisect each other. Additional properties. A. Perimeter. The perimeter of a quadrilateral is the sum of the lengths of its 4 sides. B. Area. The area of a quadrilateral depends on its type. For example, the area of a parallelogram can be found by multiplying the length of its base by its height. It's important to note that there are many other types of quadrilaterals and additional properties associated with them. The properties mentioned above are some of the fundamental concepts related to quadrilaterals. Rectangles. Rectangles are a specific type of quadrilateral that have some unique properties. Here are the key properties of rectangles. Opposite sides. In a rectangle, opposite sides are parallel and equal in length. This means that the 2 pairs of opposite sides are congruent, have the same length. Right angles. All 4 angles of a rectangle are right angles, which means they each measure 90 degrees. This property sets rectangles apart from other quadrilaterals. Diagonals. The diagonals of a rectangle are congruent. They intersect each other at their midpoints, dividing the rectangle into 2 congruent right triangles. Symmetry. Rectangles possess rotational symmetry of order 2. This means that you can rotate a rectangle by 180 degrees around its center point, and it will look the same. Diagonal length. In a rectangle, the length of a diagonal can be found using the Pythagorean theorem. If the length of one side of the rectangle is a, and the length of the other side is b, then the length of the diagonal, d, can be calculated as d equals square root a squared plus b squared. Perimeter and area. The perimeter of a rectangle is calculated by adding the lengths of all 4 sides. Since the opposite sides of rectangle are equal, so the perimeter of rectangle is 2, length plus breadth. NTHE area of a rectangle is found by multiplying the length of one side, base, by the length of an adjacent side, height, i.e., area equals length times width. Tessellation. Rectangles can be used to create a regular tessellation, which means they can fit together without gaps or overlaps to cover a plane. These properties make rectangles useful in various geometric applications, such as construction, architecture. Square. A square is a special type of rectangle that possesses additional properties. Here are the key properties of squares. Equal sides. A square is defined by having all 4 sides congruent, which means they are equal in length. This property distinguishes squares from other rectangles. Right angles. Like a rectangle, all 4 angles of a square are right angles, measuring 90 degrees. Thus, squares are also quadrilaterals with all right angles. Diagonals. The diagonals of a square are congruent, perpendicular, and bisect each other. Each diagonal divides the square into 2 congruent right triangles. Symmetry. A square has rotational symmetry of order 4. This means it can be rotated by multiples of 90 degrees, a quarter turn, and still appear the same. Diagonal length. In a square, the length of a diagonal can be found using the Pythagorean theorem. If the length of one side of the square is s, then the length of the diagonal, d, can be calculated as d equals s square root 2. Perimeter and area. The perimeter of a square is calculated by multiplying the length of one side by 4, as all sides are equal. The area of a square is found by squaring the length of one side, i.e., area equals side squared. Regular tessellation. Squares can form a regular tessellation, where they can be arranged without gaps or overlaps to cover a plane. Squares have many practical applications in geometry, architecture, and engineering. Their symmetrical and uniform properties make them visually appealing and useful in designing and constructing various structures and patterns. Rhombus. A rhombus is a quadrilateral with several distinct properties. Here are the key properties of a rhombus. Equal sides. A rhombus has all 4 sides congruent, which means they are of equal length. This property sets rhombuses apart from other quadrilaterals. Opposite angles. In a rhombus, opposite angles are equal in measure. This means that the 2 pairs of opposite angles have the same size. Diagonals. The diagonals of a rhombus are perpendicular bisectors of each other. This means that the diagonals intersect at right angles and divide each other into 2 equal halves. Symmetry. A rhombus possesses rotational symmetry of order 2, meaning it can be rotated by 180 degrees and still look the same. Diagonal length. In a rhombus, the length of the diagonals can be calculated using the Pythagorean theorem. If the lengths of the 2 sides of the rhombus are a and b, then the length of the diagonals can be found using the formula d equals square root a squared plus b squared. Angles. The sum of the interior angles of a rhombus is always equal to 360 degrees. 2 opposite angle of a rhombus is larger than a right angle and other pair of opposite angles smaller than a right angle, less than 90 degrees. Area. The area of a rhombus can be calculated by multiplying the lengths of the 2 diagonals and dividing the result by 2, i.e., area equals d1 times d2. 2. Tessellation. Rhombuses can be used to create a regular tessellation, where they can be arranged without gaps or overlaps to cover a plane. Rhombuses are commonly encountered in various fields, such as geometry, art, and design, due to their distinctive shape and symmetry. Their properties make them useful for constructing patterns, tiles, and diamond-shaped structures. Trapezium. I assume you are referring to a trapezium as defined in some regions, which is known as a trapezoid in the United States. A trapezium, or trapezoid, is a quadrilateral with at least one pair of parallel sides. Here are the key properties of a trapezium. Parallel sides. A trapezium has one pair of parallel sides. These sides are referred to as the bases of the trapezium. Non-parallel sides. The other 2 sides of a trapezium are called the legs or lateral sides. These sides are typically not equal in length. Angles. The angles of a trapezium can vary in measure, depending on the specific trapezium. However, the angles at the base, the angles formed between the bases and the legs, are supplementary, meaning their sum is equal to 180 degrees. Midsegment. The midsegment of a trapezium is a line segment connecting the midpoints of the non-parallel sides. The length of the midsegment is equal to the average of the lengths of the bases. Height. The height, or altitude, of a trapezium is the perpendicular distance between the bases. It is also the length of the line segment connecting the bases that is perpendicular to both bases. Area. The area of a trapezium can be calculated by multiplying the sum of the lengths of the bases by the height and dividing the result by 2, i.e., area equals base 1 plus base 2 times height 2. Trapeziums have various applications in geometry and real-life situations, such as in architecture and engineering. They often arise when dealing with sloping surfaces, roofs, or in the context of geometric puzzles and problems. Kite. A kite is a special type of quadrilateral with specific properties. Here are the key properties of a kite. Two pairs of adjacent sides. A kite has two pairs of adjacent sides that are congruent in length. This means that the lengths of the adjacent sides are equal within each pair. Diagonals. The diagonals of a kite are perpendicular to each other. One diagonal is the line segment connecting the two non-adjacent vertices, while the other diagonal connects the remaining two vertices. Diagonal intersection. The diagonals of a kite intersect at a right angle and divide each other into two segments of equal length. Angles. The angles of a kite vary in measure. However, the angles between the congruent sides, adjacent sides, are equal. Additionally, the angles between the non-congruent sides, non-adjacent sides, are equal. Symmetry. A kite possesses a line of symmetry. This means that it can be folded along the line of symmetry so that one half of the kite matches the other half. Area. The area of a kite can be calculated by multiplying half the length of one diagonal by the length of the other diagonal, i.e., area equals d1 times d2. 2, where d1 and d2 are the lengths of the diagonals. Kites are often used in recreational activities such as kite flying, but they also have applications in geometry, design, and architecture. Their unique shape and properties make them interesting to explore and work with in various contexts.